Cement is a fine powder. It is a key ingredient in concrete. The fineness of cement is important. It tells us about the size of the cement particles. The fineness test of cement measures this size. This test is crucial for ensuring the quality of concrete. The fineness of cement impacts its properties. It affects how easily cement mixes with water. It also determines how strong the concrete will be. The fineness test helps engineers make informed decisions. They can choose the right type of cement for their project. This ensures the durability and safety of structures. The fineness test is a standard procedure. It is performed in laboratories worldwide. This ensures consistency in cement quality across different manufacturers. This test is essential for building strong and long-lasting structures. Cement fineness is crucial for several reasons. Firstly, it affects the rate of hydration. Hydration is the chemical reaction between cement and water. This reaction is what makes concrete harden. Finer cement particles have a larger surface area. This allows them to react with water more quickly. Secondly, cement fineness influences the workability of concrete. Workability refers to how easy it is to mix, place, and finish concrete. Finer cement produces a more cohesive and less bleeding concrete mix. This makes it easier to work with. Thirdly, the fineness of cement affects the strength and durability of concrete. Finer cement particles pack more tightly together. This results in a denser concrete matrix. Denser concrete is generally stronger and more resistant to wear and tear. Several methods are used to determine the fineness of cement. Two commonly used methods are the sieve test and the Blaine air permeability test. The sieve test involves passing a known weight of cement through a sieve of a specific mesh size. The amount of cement retained on the sieve is measured. This indicates the particle size distribution of the cement. The Blaine air permeability test measures the specific surface area of cement. This is done by measuring the time taken for a specific volume of air to pass through a bed of cement. Finer cement has a larger specific surface area and will therefore offer more resistance to airflow. Both the sieve test and the Blaine air permeability test provide valuable information about the fineness of cement. This information is essential for quality control and ensuring the desired properties of concrete. Section 4. Impact of fineness on hydration and strength. The fineness of cement significantly impacts the hydration process and consequently the strength development of concrete. As mentioned earlier, finer cement particles have a larger surface area. This leads to faster hydration. Faster hydration means that the concrete will gain strength more quickly. This is desirable in many construction projects where time is of the essence. However, it also means that the heat of hydration will be released more rapidly. The heat of hydration is the heat generated during the chemical reaction between cement and water. While generally beneficial, excessive heat generation can lead to thermal cracking in concrete. Therefore, it's crucial to balance the benefits of faster strength gain with the potential risks of thermal cracking when using fine cement. Section 5. Potential drawbacks of fine cement. While fine cement offers several advantages, it's essential to be aware of its potential drawbacks. One significant drawback is the increased risk of shrinkage and cracking. Finer cement requires more water for hydration. This can lead to greater shrinkage as the concrete dries. Shrinkage can cause cracking, especially in restrained concrete elements. This can compromise the structural integrity and durability of the concrete. Another potential drawback is the higher cost associated with producing fine cement. The grinding process required to achieve a finer particle size requires more energy and resources. This translates to a higher cost for fine cement compared to coarser cement. Therefore, it's crucial to consider the trade-offs between the benefits and drawbacks of using fine cement based on the specific requirements of the construction project.